So we're going to look into this video like removal of if-else statements with functional polymorphism in Java. Okay, so I'm not going to present any slide. Rather, I'm just going to show the code, and we are going to see everything hands-on. Okay, so if you are looking for some theory, please don't be here. We are just going to work hands-on. Okay, yeah. So the first point is let me move into a better mode. Okay, so there are 3 parts when we are looking into if condition. So something might be like a simple if condition. For example, if you see here, we are just calculating the distance in miles is less than 50. If it is, we are returning 350, or else we are returning 400. So actually, this kind of thing, we don't need polymorphism or anything else. We can just go for we can just leave as it is. Actually, for example, it is not going to make things hard, and this code is not going to make us like we are going to end up in some unmaintainable code. So in this case, this if else is fine, but if you still think actually like I don't like having if else's, you can always there is also always an option for ternary operator, so just use it. And this should look good. Okay, so I think we have tests as well, so I'll just uh, run the test to ensure like we are not breaking anything. That is the core idea, right? Whenever if we are doing something else, changing some methods, we should always have tests. Okay, so let's wait. Okay, so it's fine. It successfully completed that. That's fine. And there is one more kind of if condition. Mostly, what it will do is it will be just having like an enum or a single character like this. If customer type equals platinum, etc., etc. And the same thing can be done in switch as well. For example, switch customer type, and then based on the customer type, return some gift worth 50, 30, or 10. Okay. So this cannot be done as a ternary operator stuff, right? So this, but this can be done in a typical polymorphic way because it was just equals. So all we just need to find is we need to create map and then get value based on the enum or whatever value it was. So in this case, what I'm going to do is I'm going to create a map. The conditions are from customer type. So for the conditions, we need to specify the customer type because I'm going to work on it, and the return type is some gift worth 30, which is obviously a string. So I will mark that a string, and then I will ask as responses. I think that might be a name. Yeah, that might be a good name as well. Okay, yeah. And then unreachable statement, we don't need any of those. We'll just comment it out. Responses dot put customer type dot platinum, and then it should return this value. Okay, and then we have gold, and then there is else actually. Okay, so we don't need this. We will give it afterwards, and then I need to change this as 30. Okay, so else I don't know what condition it is, but yeah, that's fine. So when I am going to return it, all I need to do is I need to verify that the value which is platinum or gold is available part of responses. How can I do that? Just we already have uh, this thing called contains key. We can verify the customer type is present there. If it is present, we can just identify responses dot get customer type. If it is not present, we will just give this one because this is the default, right? And then we need to run the test. That is the core idea. If we are not running test, it won't ensure that we are working fine or we are doing something good. Okay, so it's fine. So this is another type of conditional replacement. The first one is similar if else, a single condition, multiple if else, or this can become in switch case as well. Okay, yeah, switch case we can just convert that into polymorphic way. And also I believe you don't have to put this inside. You can make this outside by creating this as a static variable, because each and every time an object is going to be created, there is no point actually. Yeah, if you want you can do that, or let it be here, it doesn't make much difference. Fine. So we have completed this one based on equal condition and static result, use hash map and return it. And then the next thing is based on rules, calculate price and apply discount. For example, what this method is doing is whenever the products has been given, it will try to calculate the total price. If you go here, if you see here, it is just calculating the total price, and then it was identifying a number of products. Okay, I think total product doesn't make sense, right? I will make sure it was a number of products. If number of products is greater than 15, you need to give 10% discount. Number of products greater than 5 and less than 15, you need to give 5% discount, or else you can apply 1% discount. Okay, so this is the core idea here. If you see, it was not a static thing as we have. We used to have just some static, like some gift worth 30. Everything is a calculation. We have a calculation which will do for everything, whatever inside. So we need to come up different way. Most of the people, if you look into, they have come up with like creating multiple classes, identifying, converting the existing things into enums and all other stuff. We are not going to do that. We are going to come up with different way, because whenever if you see any condition, okay, if condition, there is a condition here and then there is a block. Okay, so the block currently is returning double actually. If based on your requirement you can do things, but whatever the block which you see, it should always return, or it should always return one particular value. It should change one particular value. Okay, so we need to identify what it was. So the condition is a boolean, and then the execution, it is always a double. Okay, so it might be double in this case, and it might be some employee object, it might be some product object, it might be any object. So what we need to do is we need to come up with a generic solution which will help us to sort out all this thing. Okay, so the generic solution we need to sort out is, we will do something like, we will have where is this thing? Okay, we will have a condition which should return a boolean, and based on the condition we might need to execute a particular process which will return some variable, and we are assuming as of now it is going to return only one variable, because that is the core idea here. We cannot return multiple variables. For example, in if condition, you should not, if you are trying to have multiple variables within, you might need to merge all those things and get it into the same class. But the core idea, that is the execute process should return a result, might be of anything, like in this case it was double. Okay, so condition process, and how can we create an object like that? We will create a class called rule, and the execution process might keep on changing, so we don't want to restrict that to have only double. We can have we can generalize it by using T. For condition, we will have a boolean, and we will use the supplier interface. Supplier interface is, it will accept nothing. Okay, accept nothing, and returns of some type. Okay, so for both of this, for condition we will have a supplier of boolean. Okay, and then for execute process we will have a supplier of some generic variable T. Okay, so that it can be used across anywhere. And now we will create a class rule, and then we don't have to worry much about the scope operations. And condition, it is going to be of supplier boolean and then another thing is supplier of T process. So I'm specifying this as generic. Okay, and then one more thing is I'll just create a constructor with both the values. Okay, we are good. So as of now we are good. We have a rule and it has a condition, and we have a process as well. Okay, so the first thing which we need to do is we'll just create an option of identifying the number of representations. For example, here it was a 10% discount, and then 5% discount, and then 1% discount. These are all the three different conditions we have. So for each and every condition we might need to represent it. Probably we can represent it by enum, so they can able to identify further for computing things. Okay, so 10%, 5%, 1% discount. So let me create a enum of we will call that as discount type, and then let that be like 10% and 5% and then 1%. Okay, so this is just for naming these things. The naming is important. Only then we could able to create and map, do all the stuff. Okay. And then the next thing is we might need to create a rule for each and every discount type. Before that, let me do one thing. Let me create a helper class which will create me a rule. Okay. So let me create like we need a rule of double, right? Yeah. So we need a rule of double. I'll call as create rule, and then I will get supplier of boolean condition, and then supplier of double, right? Yeah, double process. Return new rule of double condition comma process. Okay, so this is just a helper actually, so the code will look good, so that's the reason I'm doing it. Okay. So we need to create rules for the first one is our 10%, right? So I'll do one thing, just create rule for 10%. So what are all the variables being used here? One is number of products and another thing is price of products. Okay, so if I need to pass these parameters, whatever parameters which is going to be used within the block, we need to pass those things. So here one is price of products, and another thing is number of products. Okay, so and we are going to write conditions for each and everything. So you all know that it was just lambda, and for 10% the condition is number of products greater than 15. Okay, so the condition I have marked number of products greater than 15, and then for a process, this is the process, right? Yeah, this is the process. Just copy it and have a thing and do it. And if you feel like having two variables make more sense, you remove it, and then just put it something like this, so it will look good. Okay, so 10%, the first parameter is condition and the second parameter is a response. Okay, so this is one thing, and then we need to do it for 5%. 5%, the condition is and then the response is it's just 5.0, right? Yeah. Okay, and then we need to create for 1%. And then We need a else here actually, because we cannot say something directly here in this approach. So we can say like number less than or equal to 5. Okay, so that is the only case here. So in here, number less than or equal to 5, and then the percentage should be 1. Okay. So 5%, 10%, and 1%, all these three rules has been done. So even if there is any other thing which we are going to come for 20 people, you need to do some other option, you can just add this information. Okay. And also one thing is important, the first one is 10%, second one is 5%, third is 1%, right? So we need to ensure the same way you need to do 10, 5 and 1. So that it will go like the flow, or else it might do some other stuff. So we might need to take things. So if you see here, we have a condition and process for 10%, condition and process for 5%, condition and process for 1%. Now all we need to do is we just need to orchestrate all these three conditions. How can we orchestrate? This is a rule is fine, and then we need to have a representation. We can represent by this discount type, right? So we will have something called map, which will be represented by discount type, comma, rule of double. Okay, so for each and every discount type, which is either 5%, 2%, each it will have a condition and process. So create rules. Okay, and then we will have the same thing, because we just need these information for pointing everything. And then we will create what can we call actually? Okay, so we'll call just rules, right? Rules equal to, and then rules dot put. The first one is 10%, right? So what we'll do is discount type dot 10%, comma, create rule for 10%, price of products, comma, number of products. Okay, and then the next thing is 5%, create rule for 5%, price of products, number of products, and the final thing is 1%, create rule for 1%, price of products, number of products. Okay, and we just need to return these rules. Okay, we got it. We got everything else here, and finally we just need to execute, and we need to find out what is what. I'm just going to comment it out, and we are going to use the same thing here. So rules equal to create rules, price of products, comma, number of products, and then we will just find out what it was. So here we cannot go into the rules, we need to go into the conditions, we need to iterate from the conditions. Okay, so what I'm going to do is I'm just going to use stream dot off, and then the conditions are in discount type is the representation. So dot values, and then dot filter discount type. I need to identify whether the condition is matching. Okay, all the conditions are available in rules. Okay, I need to find out the rules, and then I need to match the conditions. So in this case I'll do is rules dot get discount type dot condition dot get. Okay, so what it will do is it will just execute the condition, and if it is true it will return filter true. And then finally what I need to do is I need to go for map to converting it. Again I am going to get only discount type. The same thing, rules dot get discount type dot process dot get. Okay, and then finally here find first, and then or else I'll just give some 0 or null. I think it is better than null. So you need to have clear understanding of how supplier works. Supplier is whenever if you call the method .get, it will automatically execute and it will return a value. So in this case, it will return a Boolean value by evaluating the condition here, which is the number of products greater than 15. And then if it is successful, it will come down. And then once it is going to come down here, it will try to execute the process. Process is nothing but the price of products minus price of products into 10.0 slash 100. Okay, so this will ensure like converting our regular Ifelse to something. So let me first run this test so to ensure everything is working fine. Okay, everything is working fine. So why do we need to go this way? What is wrong here? The problem is open close principle. Whenever there is a new requirement coming, if we need to change something else or if we need to add something else, we should not look into the existing method and change it. We need to create or we need to do new method into changing. For example, someone is going to come tomorrow for 20%. If the products is number greater than 20 or something, all you are going to do is you're just going to add one rules here, like rules dot put some 20%, and then create rule. You will create a new method and then perform calculations there. So we are not changing or touching the existing thing. Whenever if we are not changing or touching the existing thing, we are adhering almost to open close principle. We are not totally 100% doing it, but we need to always go for the go towards the excellency. So only area where we are going to change is the create rule section, but you know that it was just a small thing. It's not a big deal. It's not going to be a big change, and all your business logic is going to remain there it is. So create rule for 10% will take care only for the 10% stuff, but here the calculate price and apply discount will be taking care for each and everything else. So there is a possibility that you might miss most things, and then the class itself would be hard to read and all of that stuff. But if you see here, we could able to see everything. It's readable. It's pretty much readable, not bad. You can do things like that. Okay, thanks for looking into it. I have placed all the source code in the link, description link. You can just go there and watch it. Okay, thank you.